Okay, so my slide is visible to everyone.
Yes, sir.
Okay, good. So once again, good evening to everyone. So today we have a sixth class, and today we can discuss the second unit. So that is a power electronics converter used in electric drives. Okay. So in the previous class, that is the first class, we already discussed the component of the load torque, classification of the load torque, that is a time and energy losses in the transient operation, and steady state stability of the electric drives. Okay. So now we can discuss uh, lecture outcome from the today's class. There is a power electronics converters. Okay. Introduction of the electric vehicles, types of converter used in the electric drives, battery management system for the electrical drives. So basically second unit, that is the application of power electronics converter in the electric drives, and additional to the research topic for your MTech thesis, because I received so many call from the student how to select the research topic and what we have to do the research for your MTech thesis. Okay, so more or less this topic is a we can say the related to syllabus as well as the related to your career. So that is your MTech thesis, as well as most of the student you are in the working condition in the industry, as well as the somebody maybe the in the academic area, correct? But you want to build your career in the academic as well as the industry, then you should know about the latest technology on the power electronics converter. Okay. So just 1 minute wait. Somebody want to join the class. Yes. Yeah. So these are the outlines of today's class. Okay. So introduction to power electronics converter. So I am not spending the too much time on this topic because now you are a MTech student and also you are in the current second semester student. Okay. So we all of you know we have a four type of converter in the market. So that is a AC to DC converter. Okay. So we can say that is a converter based on the diode as well as the based on the semiconductor switch. That is a transistor as well as the thyristor. Okay. So maybe the IGBT, maybe the MOSFET. Okay. Yeah, maybe the diode. Okay. Whenever we can say diode, that is uncontrollable, and this is a controllable. Okay, so we can say whenever we can say the rectifier, there is a AC to DC converter, then we can say it is a controllable rectifier as well as the uncontrollable rectifier. Okay, so whenever we can say in controllable, that means we can use the switch that is a IGBT, otherwise the MOSFET, because these both switch are controllable. Suppose you don't want to control the supply voltage, then we can say it is a diode based rectifier because diode is uncontrollable. Okay, so we all of you know about the AC to DC converter and various type of AC to DC converter. Okay, then second one is again is a AC to sorry DC to AC converters, that is a we can say inverters. So nowadays in domestic application, every house has inverters, correct? So whenever lights cut out, then we can start our inverter, correct? So what is the role of inverter? That is a nothing but AC to DC converter, correct? Again, we have to use the semiconductor switch to design the converter, correct? So with a small level of the power rating too, we can go up to the megawatt, kilowatt rating of the inverter. Okay. Then is a chopper, that is a DC to DC converter, because based on the application, suppose you want to charge your mobile phone from the DC supply, then we have to use the chopper, correct? Because chopper is a DC to DC converter, and your mobile phone it will take again the DC, correct? So we have to make the chopper circuit, that is a maybe the higher voltage to lower voltage, yeah, maybe the lower voltage to higher voltage. So we can say buck converter, boost converter, buck boost converter, Kirk converter, correct? So majorly we can use this type of converter for the design the chopper circuit based on the application. So again, power rating is a watt to kilowatt megawatt. Last one and most important, that is a cyclo converter and that is a AC to AC converter. Suppose some load required the AC voltage, but again there is a controllable AC voltage, then we can use cyclo converter. Okay, so maybe 230 watt AC supply to maybe the 150 watt AC supply. Okay, 230 to 150 volt AC. Okay, so we have to convert the voltage regulator. We have to down to voltage magnitude, correct? That is a 230 to 150 volt AC supply. Then we have to use the AC to AC converter, and that is a cyclo converter. So summary form, we can say majority of the power electronics converter we are using only four type of converter, that is AC to DC converter, DC to AC converter, DC to DC, and AC to AC converter. Correct? So these are the major power electronics converter which we are going to use in the electric vehicle. Correct? Done. Now, how we can use the power electronics converter in electric drives? Correct? In the previous class, in the previous slide, we already discussed the types of the converter, but how we can use this converter in the electric drives, correct? So now slide number 5. Okay, so first and most old application, still most of the industry use this application, that is a variable frequency drive. Okay, variable frequency drive, that is a VFD. Okay, 80 to 85% industry still using this drive, that is a variable frequency drive, to control the speed of electric machines. Okay, any type of machine, maybe the induction, DC, synchronous, any type of machine, industry use the VFD, correct? So power electronics converters such as the inverters are widely used in the variable frequency drives, correct? So we have to use the power electronics converter to design the VFD. They convert the fixed AC voltage and frequency from power supply to variable voltage frequency, variable voltage and variable frequency. That's why we can say variable frequency drives, correct? Okay, to allowing the precise the control of the motor speed, because ultimately we have to control the motor speed, otherwise the motor torque. But 80 to 85% we have to control the speed of the motor. So that's why we are working on the control algorithm, various control algorithm available in the market to control the speed of the your motor, correct? VFD are extensively used in the industry application for energy saving and process control, correct? So ultimately for the energy saving, because by using the VFD we can save the energy because efficiency is very good. So ultimately we can save the energy, and easy to control the VFD to control the speed of the motor. So that's why nowadays AI technology is there, but still people use the VFD for the industry application. Okay, so first and most important application, there is a VFD, variable frequency drive. Second one is a electrical drives, electric vehicle drives. Okay, so second application, there is a electric vehicle drives. We all of you know about the, we all of you know about the electric vehicle, correct? Electric vehicles and hybrid electric vehicles. Power electronics converters are employed to control the energy flow between the battery and the electric motors. Whenever we can say electric vehicles, it means we have to control the power flow between the battery and the motor. Whenever we can say power flow control, it means we have to use the power electronics converter. So ultimately we can say power electronics converter is nothing but heart of the any application. It is not only for electric vehicle, it is not only for communication signal, but any application, everywhere we are using the power electronics converter, because we have to control the voltage, we have to control the current, we have to control the frequency. Okay. Converter include the inverters in the DC-DC converters, manage the power distribution, and enable the regenerative braking and control the speed of the electric motor. Okay. So there are the many roles of the power electric converter in the electric vehicle because we have to manage the power distribution, we have to manage the regenerative braking, okay, and we have to control the speed of the electric motor. So you can see as your branch is a power electronics and drive, so your demand is very high because everywhere we have to use the power electronics converters, okay, and everywhere we have to use the drives. And whenever we can say drives, it means we have to control the speed, otherwise the torque of the motor. Correct? Third application, there is a renewable energy system. Okay, maybe some student want to do the research on the renewable energy system for the MTech thesis, yeah, maybe the seminar topic. Then you can use this power electronics converter in the renewable energy system. And whenever we can say renewable energy system, it means that is a solar, wind, bio, yeah, any type of renewable energy source. Okay, and suppose you want to use this renewable energy system in your domestic application as well as the industry application, then you must have to use power electronics converter. Okay, so power electronics converter are essential in the renewable energy system where electric drives are used to harness the energy from source like wind turbine and the solar panel. Because output of the renewable energy, it is not a constant, not a fixed, it is a variable, correct? It is a varying with respect to time. And your load, that is your constant load, correct? It is required the fixed voltage, correct? So that's why we have to give the power electronics converter for the domestic application as well as the industry application. Okay, done. So that is a renewable energy system. Okay, fourth one, that is a UPS. Yes, we know very well about the UPS, that is uninterrupted power supply. Okay, so that is the same like a battery. Okay, in UPS system, power electronics converter provide the seamless transition between the utility power and backup energy source. Whenever we can say backup, it means that is your battery. Okay, so UPS, that is an uninterruptible power supply. It is a nothing but your some kind of your battery. Okay, and it is related to your battery. Converter maintain the stable and reliable power supply. Yes, we want a stable power supply. If power supply is not stable, then it will create the harmonics. It will create the uh, THD, it will reduce the efficiency. Okay, that's why we want to maintain the stable voltage, so reliable power supply during the grid disturbance or power outage, ensuring the continuous operation of critical equipment. Okay, if you have any critical equipment and you want 24 into 7 power supply, okay, then we can use the UPS for that device. Okay, then we can say again it is a major role of power electronics converter in the UPS. Next one, that is a industry motor drive. We already discussed whenever we can set the drives application, whenever we can set the industry load, 70 to 75% majority power consumed by the industry nowadays. Okay, and only 30%, 30 to 40% power consumed by the domestic load, correct? So industry motor drives, that is a power electronics converter, are extensively applied in the industry motor drives for the various applications such as a fan, pump, conveyor. Majority of the power supply that consumed by the electric industry, consumed by the industry load. Okay, and that industry load is majority by the motor drives. Okay, so this converter enable the precise speed and torque control. Okay, so suppose like robotics application. Okay, so that is a speed control is a precise. Okay, as well as the torque control, leading to improve the energy efficiency and process control. Okay, so this converter are enable precise speed and torque control, leading to improve the energy efficiency and process control. So seventh application, that is industry motor drives application. Eight application that home appliances and HVAC system. Okay. Electric drives powered by converters are used in home appliances like the washing machine, refrigerator, and air conditioner. Okay. By controlling the speed and operation of the motor in this device, converters enhance the efficiency and overall performance. Okay. So we can use the domestic application, otherwise we can say the home appliances to control our power, to control our devices. So we can use the power electronics converter. Okay. High speed train and locomotive. Okay, so we can say the transportation system, that is a high speed trains and locomotive system. We can use the power electronics converter. How? Power electronics converters are crucial in the traction system of the high speed train and the locomotive, because we have to control the speed of the train and we have to control the speed, we have to control the torque, correct? They control the speed and torque of the electric motors. Yes, we have to control the speed and torque whenever we can see the transportation system. Okay. Ensuring the efficient and the smooth operation while optimizing the energy consumption. Okay. So we have to optimize the energy consumption. We have to increase the efficiency of the drives. Correct. Ultimately, we have to increase the efficiency of our device, our system. Correct. So whenever we can say the efficiency, then power electronics role is a major role. Okay. Second last application, that is a flywheel energy storage system, and this topic nowadays hot topic for the research domain. Okay. So for the energy storage system, we are using the supercapacitor, we are using the battery, we are using the ultra capacitor, but current hot topic, that is a flywheel energy storage system. Okay, if somebody want to do research on the energy storage system, then maybe you can consider this topic, that is a flywheel energy storage system. Okay, so this is a nowadays hot topic because we have to store the energy, correct? So then how we can utilize the power electric converter? So power electric converter are employed in the flywheel energy storage system to manage the charging and discharging of the flywheel. Similar to we have to manage the charging and discharging of our battery, maybe the lithium ion battery, or maybe the lead battery, maybe the any type of battery. We have to manage the charging and discharging, correct? So same level in the flywheel energy storage system, we have to manage the charge and discharge. So that's why we have to use the power electric converter. Okay. Converter play a key role in regulating the flow of the energy between the flywheel and the electric grid. Correct? So your flywheel, that is connected with your grid. So role of the power electric converter, that is a managing, that is a regulating the flow of energy between the two devices, that is a flywheel as well as the electric grid. Okay. So yes, students, suppose somebody want to do the research on the storage system, then maybe we can consider on the flywheel energy storage system. Okay, done. Okay, and last one, that is a aerospace application. Okay, so that aerospace application, okay, we all of know about the aerospace application. So electric drive in the aerospace applications such as aircraft and satellite utilize power electronics converter for the motor control. Okay, so then we can use the aerospace application. Okay, and medical devices. Yes, nowadays medical, that is a critical role. Okay, in our life. Okay, we don't know about our life situation. Correct. So power electronics converter are used in the various medical devices, including the pumps, ventilator, robotic surgery system, and everywhere. Because nowadays, in many hospital, robots are used to surgical system. Correct. In many, even we can say in the military application, even use the robots. Correct. So everywhere nowadays we use the robots. Correct. So there is a common application, we can say the medical devices, correct? So they enable to precise the control of the motorized components, enhancing the performance and the accuracy of the medical equipment. Okay, so suppose you want to do the accuracy of your device, then we can use the power electronics converter. Okay, so these are the major application where we can use the power electronics converter. And thumb and rule is a universal. We have only four type of power electronics converter. That is AC to DC, DC to AC, AC to AC, and DC to DC. Correct? So by using these four type of power electronics converter, we have to make the all our device in the regulated weight base. Correct? Maybe the speed regulation, maybe the torque regulation. Okay, we have to control only these two quantity. That is the speed and the torque. Okay, in any application domain, maybe the medical, maybe the aeronautics, maybe the aerospace, any application, we have to control only two parameters. That is a voltage, otherwise torque. Okay, for controlling these two parameters, we have to use the various type of power electronics converter. Done. So these are the major application of power electronics converter where you can implement your control algorithm in different applications. Now we can discuss on the electric vehicle. Correct? So now we can discuss on the electric vehicle. So before going to detail about the electric vehicle, first we can understand overall major components of electric vehicles. Okay. So we can say we have a three subsystem for the electric vehicle. Just 1 minute. Yes. First system, that is a electrical propulsion subsystem. That is the first one. We can say first one. Energy source subsystem, that is the second one. And auxiliary subsystem, that is a third one. So we have three subsystems for the electrical system: electric vehicle, electric propulsion subsystem, energy storage subsystem, and auxiliary subsystem. Okay. So one by one we can discuss. Okay. One by one we can discuss. That is a electric propulsion subsystem. That is a electronics controller. Yes, there is a power electronics controller, power electronics converter, electric motor, and mechanical transmission. Okay, that mechanical transmission system, that is a wheel. Okay, and mechanical transmission system, because we have to transfer the mechanical power to the to the wheel. Correct. So this is under the electrical population subsystem. Correct. Now second one is the energy storage subsystem. So we have to manage the energy. Okay. So there is an energy management unit, energy refueling unit, and energy source. Okay. So that is basically the energy source subsystem. Then we can say auxiliary subsystem, that is auxiliary power supply. Okay, for the small devices to charge your mobile, for the FM radio, air conditioner. So that is auxiliary power supply. Temperature control unit. Yes, in every car we have a AC, so we have to control the temperature. Okay, so for that AC we need to give the power supply. That is auxiliary power supply. And power steering unit. Okay, so majority we can say we have only three subsystem while we can discuss the electric vehicle. Okay. So maybe you can consider any component for your research work. Okay. So maybe the electric motor, maybe the power converters, maybe the energy management unit, maybe the energy source, that is a renewable energy source, non-renewable energy source, auxiliary power supply, how you can manage the auxiliary power supply, how you can control the temperature of the AC. Okay, how you can control the temperature of your battery. Okay, so you can consider any topic for your research work. Okay, as you are the power electronics and electrical drive student. Okay, now yes, we have a many type of electric motors for the electric vehicles. So which type of motor we have to use and what are the advantage and disadvantage? So just I am briefing on this slide. We have a four type of electric motors nowadays people use in the electric vehicle, starting with the BLDC motor, that is a brushless DC motor. BLDC stand on brushless DC motor. PMSA motor, that's a permanent magnet synchronous motor. Again, we can say this both motor, that is a permanent magnet motor. Okay, both are the permanent magnet motor. Only minor difference, that is a back EMF. Okay, so BLDC back EMF, that is a tapezoidal, and permanent magnet synchronous motor back EMF, that is a sinusoidal. Okay, so there are the minor difference between these two motors. Okay, third motor, that is an induction motor. We know very well about the induction motor. And fourth one, that is a special electrical motor, we can say the switch reluctance motor. I think Barrister already covered this topic, that is a SRM, controlling of the SRM motor. Okay, so there is a switch reluctance motor. So nowadays we use this whole type of motor in the electric vehicle. Okay, so what is a key challenges for the BLDC motor? First one, there is a high cost of the magnet. Torque ripple is also high. Reliability issue, because torque ripple is high, then reliability also issue. EMI, acoustic noise, fault tolerant. Okay, and then less efficiency. Okay, because there are the many issue with the BLDC motor, that's why it is a less efficiency compared to the others motor. Okay, but what about the control technique? So we can say the field oriented control, direct torque control, model predictive control, intelligent control. Okay, before the today I discussed with one student, and he told me so he want to do the research on the BLDC motor with the different control algorithm. So we have a many type of control algorithm available in the market. So depend on your requirement, we can implement the control algorithm for our drives. Okay, maybe the BLDC motor, yeah, induction motor, yeah, PMSM motor. Okay, done. And design topology, opening stator slot. So this design topology majority for the design of your motor. Okay, so mechanical design, so physically design. Okay, suppose you are interested in the physical design of the motor, then you can use this type of configuration. Okay, but this is totally, that is a mechanical design part. Okay, so you have to design to your stator, rotor, slot, everything. Correct. Now, what about PMSM? PMSM is higher cost magnet. Okay, because of the cost of the magnet, there is a very high. Demagnetization, there is a key challenges. Torque ripple, fault tolerant. Okay, so as I said, we have a BLDC and PMSM, both are the same motor, only minor difference, that is a back EMF. So you can see key challenges also same. Okay, what about control technique? There is a low cost ferrite material, FOC, DTC, state vector modulation, model predictive, PTC, SMC, intelligent control algorithm, that is artificial intelligence based, fuzzy logic based, machine learning based, sensorless control algorithm. We have a many control algorithm available. Based on your choice, based on your expertise, you can choose any control algorithm to control the speed of the PMSM. Okay, and again, this is your mechanical part. So there is a design of the various motor. What about induction motor? There is an old motor in the market. That is a material loss, because there is a copper losses and aluminum losses, higher coal losses, and low efficiency. Yes, induction motor is a very rugged application. We can use the very rugged, okay, but that is a low efficiency because losses is very high. But what about control technique? Higher conductivity material, that is material cost trade off, sensorless control, FOC, DTC, MPC, and PTC. So these are the different control method to control the induction motor. Okay. Last one, there is a SRM, switch reluctance motor. There is a less torque density. Key challenges: high acoustic noise and vibration, because high torque ripple. Okay, because operation of SRM, I think already discussed Bharat sir in the class, because there is a, we have to operate the every power electronic switch, correct? So there is a SRM operation, switch reluctance motor. I am not going to detail about the operation of the each and every motor, because it is not a part of the syllabus. Okay, but if somebody want to do research on this type of motor, then we can personally discuss over the phone how we can operate the SRM and how we can control the speed and torque of the SRM motor. Okay, but I am not going to discuss in this class about the detailed explanation on the on the different type of motor, correct? So this lecture is only for your just overall knowledge, overall research domain across the globe, okay? And this is a part of the our syllabus, that is a second unit, okay? So types of the electric vehicle. Yes, we have a four type of electric vehicle. So first one is a hybrid electric vehicle. So we can say IC engine plus battery. Okay, that is a hybrid. Plug-in hybrid vehicle. That is a IC engine, battery plus plug. Okay, battery operated electric vehicle. So there is a only battery. There is a without any IC engine. There is a battery operated electric vehicle. Okay, and fourth one, that is a green hydrogen vehicle, otherwise we can say the fuel cell electric vehicle. And nowadays that is your green hydrogen. Nowadays people are working on the green hydrogen vehicle, and that is nothing but a fuel cell electric vehicle, because there are so many disadvantages in the electric battery operated electric vehicle. So that's why people are now thinking how we can replace the battery operated electric vehicle by the fuel cell electric vehicle. Okay, so maybe you can consider this topic, that is a fuel cell electric vehicle and how we can control the fuel cell electric vehicle. So that is also part of your topic. Okay, then now new electrical energy storage system. Okay, because storage is the most important thing whenever we can say the electrical system, electric vehicle. Okay, so these are the just overall control diagram of the new electric energy storage system. So we can say the microgrid system, then AC to DC conversion, because power electronics converter is there. So we have to convert the microgrid into the DC power supply. Just 1 minute. Okay. Yeah. So once we have a microgrid system, then we have a AC power supply. Then we can convert into DC power supply by power electronics converter. PEC stand on the power electronics converter. Correct. From the power electronics converter V to G and G to V, that is another research topic. That is a V to G and G to V. That is a vehicle to grid, and grid to vehicle. So you can see everywhere we are using the power electronics converter. Without power electronics converter, we cannot do anything. Correct? So that's why I choose this topic, and that is a part of syllabus and application of power electronics converter in the electric vehicle. So every domain, every step, we have to use the power electronics converter. Maybe the small power electronics converter, maybe the big power electronics converter, maybe the high switching converter, maybe the low switching converter. Correct? Then it is a fuel cell, again power electronics converter, battery package, again power electronics converter, super capacitor, again power electronics converter. So you can see, suppose you want to use the fuel cell, yeah, battery package, yeah, super capacitor, again you have to use the power electronics converter. Once you have a DC bus voltage, that is a constant bus voltage, then again you have to use the power electronics converter, because now you have to control the speed of your motor, correct? So here you have a constant supply voltage, but you want the variable supply voltage for your vehicle. Okay, maybe the steady state operation, yeah, maybe the dynamic operation. Then you have to control your supply voltage. So that's why we have to use the power electronics converter, correct? So this double-sided arrow, it is showing the bidirectional flow, okay, in the diagram, and single direction, that is your unidirectional flow of the control diagram. Okay, so this is the just overall of the power electronics converter, where we can use the different type of energy storage element, maybe the fuel cell, maybe the battery package, maybe the super capacitor. Okay, and then we have to use the power electronics converter for the electric vehicle. Okay. Yes, till now any confusion, any query? Yes, student. Still now any confusion, any query?
Hello, sir.
Yes.
We have heard about the G2B, B2G vehicles. Sorry, B2G system nowadays.
Mm-hmm.
Please elaborate about this.
V2G and G2V.
Yes, sir.
Yeah. So V2G and G2V is nothing but, suppose you have a vehicle, correct? And vehicle we can store the energy by vehicle, correct? How we can store the energy by vehicle? By regenerative braking, correct? We can say we have a regenerating braking.
Yes, sir.
Regenerative braking. By regenerative braking, we can store the energy. Storage energy, correct? Done. So this storage energy we can feed to the grid, and we can say we are selling the grid. We are selling the energy to the grid, correct? So we can earn the amount by our electric vehicle. So there is a V2G, correct? So we have an electric vehicle, okay? We can run our electric vehicle by regenerative braking operation. We can generate the electricity from our electric vehicle. We can store this electricity in our battery, okay? There is a storage energy system. And once we store the energy, then we can again this energy we can feed to the grid and we earn the amount. Okay, maybe the 5 rupees per unit, maybe the 10 rupees per unit, maybe the 3.5 rupees per unit. So whatever unit you can selling to the grid, so you can earn the amount, correct? So that is a V2G technology.
Sir,
Okay.
is not there any problem of stability in the case of B2G?
Can you just repeat? Is there any
Is not there any problem of stability?
pro mobi stability? What is a pro mobi stability?
Problem, sir.
Problem.
Instability problem.
Yes, so that's why we have to use again the power electricity converter, because here you can see the storage energy that is a DC. We cannot store the energy into DC, AC, correct? Always
Okay,
energy
sir.
storage that is a DC, and grid is always AC, correct? So
Yes,
you
sir.
have to convert the energy AC into DC, DC into AC, correct? Then it is a instability. Operation is a instability. Okay. So stability, there is a issue while operate V2G. To resolve this issue, stability issue, we have to use the advanced power electronics technology. That is a main role. Suppose somebody working on the V2G, then role of that engineer only we have to design the control algorithm for the stability. How we can design the control algorithm so our overall system is stable, not the unstable. That is a main issue in the V2G. And this issue is for the both, maybe the V2G or G2E. Correct? So there is a
Okay,
part
sir.
of your research. So how we can design the control algorithm for the overall stability for the V2G, otherwise the G2V. Got it?
But to connect with the common DC bus, sir,
Mm-hmm.
uh, we should use droop control.
Drop control, yes, possible.
Okay.
That is possible, yes. And nowadays people also using this type of drop control for the DC bus. That is also possible. You can find the many research paper. That is IEEE conference as well as the transaction as well as the open access. You can find out the many paper.
Okay. Thank you, sir.
Okay, yeah. So background on the electric powertrain. Okay, so as a we are electrical engineering, so no need to think on this mechanical part. Okay, so no need to think on mechanical part. Just we have to think on the power electrics converter. Okay, so our role is a controller. Yes, energy storage system, power controller, and electrical motor. Okay, so you can see as a power electronics and drives engineer, our major role in the electric vehicles, there is a four component. First one, there is a controller. Second one, there is a electrical energy storage. Third one, there is a power electric converters. And fourth one, that is the electric motors. Correct? So these are the major components where we can do something for the electric vehicle. Okay, maybe the electric vehicle, maybe the fuel cell, correct? Maybe you can consider control algorithm for the electric vehicle. Maybe you can design the control power electronics control algorithm for the power electronics converters. Okay, maybe the energy storage system. Yeah, maybe the electric motor. Okay, so you can contribute yourself as an electrical engineer, as a power electronics engineer in the electric vehicle, okay, by controlling these four components. Maybe you can consider any one control algorithm, yeah, any one control domain, okay. So just keep in mind, as a electrical engineering, as a power electric trend, okay, we have to work out on the controller part, yeah, maybe the power converter part, yeah, maybe the energy storage, yeah, maybe the electric motor, okay. That is up to you. Every topic, it will create the many research domain. Suppose there is an electric motor, then you can consider any type of electric motor, and then you can start working on the fault diagnosis and condition monitoring. Yeah, maybe you can design the control algorithm for the speed and torque. Yeah, maybe you can give the regenerative braking, okay. So any topic you can consider by using these four components, okay. And there is an unlimited research topic on these four components, okay. You will get many research paper on the electric powertrains, okay, and that is related to power electronics and drives, so we can say it is a core of our area, okay. So types of the motor configuration. So just brief. I hope maybe the most of the people know about the type of the configuration. So there is a single motor. Mostly we use the single motor for the electric vehicle. Also we can use the dual motor. Okay. So one is a front side, another one is a back side. Okay. Other is a triple motor. We can use the two motor in the front side and one motor that is a back side. That is a triple motor. And nowadays, latest technology, we can say the four motor. So every wheel we can use the one motor. Suppose we have a four wheel vehicle, then we can use the four motor. And main logic behind use the four motor, because we have to control your effectively, we have to control our vehicle, correct? Okay, so we can easily control the our vehicle by using the four motor. But issue with, there is a synchronization. We have to synchronize the each and every motor, correct? Otherwise there is a issue with the stability, issue with the efficiency, okay. So suppose four motor, then we can say the more HP, high acceleration efficiency and speed. Obvious, yes, we have a four motor, so we have a high power. Or will drive handling the stability group, correct. So we have to focus on the stability, correct. So because we have to manage the stability for the every four motor. For small motor in the wheel, call the in-wheel or hub motor, correct? So we can also call the hub motor. Nowadays, common terminology, there is a hub motor in the electric vehicle. So hub motor is nothing but every wheel have a single motor. Positive and negative torque individually control in each motor. We can control the positive, negative, maybe the four quadrature operation of the electric motor that we already studied in the first unit, correct? Torque torque control in the each in wheel motor are more complex. Suppose you want to control the torque for the each and every motor, each and every wheel, so that is a complex. Okay, so we can say overall complex structure for the uh, different type of motor configuration. Okay, so yes, students, so please remember there is a single motor electric vehicle, dual motor electric vehicle, triple motor electric vehicle, and four motor electric vehicle. Every configurator has a advantage as well as a disadvantage. Okay, so depend on your requirement, you can choose the different type of configuration. Okay, So these are the just overview of the types of motor. There is a BLDC motor. So on the outer part there is a stator. There is a your winding, and that winding is a similar to the like induction motor, but this winding is a concentrated winding. Okay, concentrated winding. Okay, so there is a concentrated winding. Okay, in the case of the PMSM, there is a distributed winding. Distributed winding, it is the same like the induction motor. Okay, but in the case of BLDC and PMSM, on the rotor side there is a permanent magnet. Okay, so this is the same like the BLDC and PMSM motor. That's why we can say it is a permanent magnet motor. Okay, only difference, there is a concentrated winding as well as the distributed winding. Induction motor, all of you know about the induction motor. And SRM motor, that is the switch reluctance motor. Outer side is a stator, and there is a shaft. Okay, and there is a this part is a rotor. Okay, so in the rotor there is a no winding, so we can say losses is very less. Okay, but in the case of the induction motor, that losses is very high. Okay, so majority these four type of motor we can use for the electric vehicle. Yes, source of the torque ripple. Nowadays, there is a major challenges part in the BLDC motor, induction motor, yeah, any type of motor, because torque ripple ultimately create the acoustic noise and vibration. Correct. So, source of the torque ripple in the BLDC motor, yeah, any type of motor, because this is a common motor structure. Okay, that is electromagnetic torque, motor nature, okay, and current communication, computation, and PWM scheme. Because we have to control the speed, we have to control the voltage, correct? And whenever you control the voltage, it means voltage is directly proportional to the speed, correct? And we have to control the voltage by PWM. And PWM is nothing but power electronics. And whenever we can say power electronics, then we have to control the PWM. Okay. So by PWM switching operation, it will create the torque ripple, and torque ripple will create the acoustic. Torque ripple will create the vibration, and that vibration it create the acoustic noise. Then nobody will going to purchase your motor. Correct. If higher noise, higher vibration, higher torque ripple, then ultimately reduce your efficiency. So this is the another research topic for your MTech thesis. You want to reduce the torque ripple by design side, otherwise the by controlling side. Okay, there is a two-way to reduce the torque ripple. Then ultimately you can reduce the acoustic noise and vibration. Okay. Yes, so these are the many techniques to mitigate the torque ripple of BLDC motor. I am not going to tell you each and every technique. Yes, you can read this technique, and suppose you are interested to do the research for your MTech thesis, then you can choose any one topic. There is a modified PWM control, DC bus voltage control, current control based technique, phase conduction based method, model predictive control method, direct torque control method, FOC, model predictive control method, and soft computing techniques. Okay, and additionally there is a artificial intelligence technique. Okay, so there is a AI technique. We can say the AI technique, and that is the latest technique. Okay, so suppose somebody want to do the research on the torque ripple reduction for the any type of motor. There is a BLDC induction motor, maybe the induction motor, maybe the PMSM, maybe the SRM. Please go through this table. There is advantages and disadvantages for the each and every method, but I am not going to discuss this method in this class because this is a part of the syllabus, but this is not a detailed analysis of the syllabus. Okay, but I am giving this table here for your kind information. Suppose somebody want to do the research on this. Okay. So now there is a control algorithm technique, correct? So we will discuss this topic in the detailed mathematical explanation in the from the third unit. Okay. There is a FOC technique to control the BLDC motor. Okay, so this is a battery main supply voltage source inverter. There is a VSI Paulitz's converter, and this is a BLDC motor. Okay, so we have to control the voltage, then we have to take the feedback. Okay, so this is a Clark transformation. We already studied in the first semester and implemented in the MATLAB. Okay, and why we have to do the Clark and Park transformation. Okay, I am not going to explain again and again. Okay, so this is a just Park and Clark transformation, then inverse Clark transformation, and ultimately we have to generate the PWM for the voltage source. Correct? And we have to control the speed. Okay, so this is a speed feedback. We can say this is a speed feedback. Ultimately this is a reference speed, and we have to reduce the error. So this is a PI controller, and again this is your reference speed, and we have to control the torque. Okay, so you can see torque control loop and the voltage control loop. So voltage control loop is always outer loop, and torque control loop is always inner loop. Correct? So we can say the two loop control algorithm. Okay, so there is an inner loop as well as the outer loop. Okay, so if you want to do the FOC technique for the control of BLDC motor, then you can implement this type of control algorithm in the MATLAB Simulink model. Okay, and then you can use the any type of control algorithm. There is a microcontroller, Raspberry Pi, yeah, Arduino, yeah, FPGA. Okay, and similarly there is a DTC technique. Okay, so everything is same, only difference that is a hysteresis current controller. Okay. So instead of the hysteresis current controller, you can use the any other type of controller, maybe the fuzzy logic controller, correct? But ultimately we have to generate the voltage source. Ultimately we have to generate the PWM pulses. Okay. Similar the intelligent algorithm technique. So as I said, there is a AI controller, there is a advanced control algorithm, and nowadays there is a hot topic in the market. Okay, artificial intelligence controller. So this is artificial intelligence neural network algorithm. Okay, by using this neural network algorithm, you can control your speed of the motor. Okay, done. Yes. Now I have only 3 to 4 slide, and that is a most important slide. There is a battery management system, BMS, battery management system, battery management system. Okay, that is a BMS. Okay. So you can see this diagram, there is a research domain in the electric vehicle. Okay. Suppose you want to do the research in the electric vehicle, then you can just look out this diagram. Okay. This diagram. And this diagram I got from this research paper. Okay. And this is a Science Direct research paper. It published in the 2022. And this is an overview of the battery and battery management for the electric vehicles. Okay. So you can see the wireless power drive. Okay, I think some students want to do the research on the wireless power drives. Okay, move and charger. Okay, vehicle information and energy internet, smart power electronics, sensor on chip, safety concern, fast charging, and energy density. So these are the wide area of the research for the electric vehicle. Okay. So, in the summary form, we can say the energy, power, lifetime, safety, and cost. So, these are the five major concerns in the electric vehicle: energy, power, lifetime. It means we can say the life of your vehicle, safety concern, and cost. Okay. So, if you are really interested to do the something for the electric vehicle, then you can just look out this paper. There is an overview of the battery and battery management system for the analysis of the electric vehicle. Okay. Yes, so this is an industrial value chain. Okay, so how we can do the step-by-step process for the battery management system. So we can say step number one, that is a raw material. Okay, yeah, raw components. step number 2, that is a cell production. Okay, for the battery, we have to produce the cell, and then series and parallel combination, we can produce our one battery. Then module production, okay, that is a battery module. Then based on the battery module, we have to also develop the battery pack, that is a pack assembly. And finally, this battery pack assembly we can give in the electric vehicle. So this is a vehicle integration, and then again is a recycle. Okay, because life of a battery is not infinitive, correct? After the 5 years, maybe after the 3 years, depend on the battery capacity, it will damage, correct? So we can say it is a not 100% damage, but maybe sometime it's a 70% damage, sometime maybe the 50% damage. But after the completion of the life, we have to recycle this battery. Maybe sometime we can use this electric vehicle battery in some another application. Maybe the small range of the application. Okay, maybe we can replace this battery for the another application. We can use this battery for the maybe the toy car. Okay, but it is a depend on the life of the battery. Okay, so these are the total 6 steps. I think Manoj Wagle want to do the research on the battery pack. So this is a very helpful to you to how to recycle the battery and how we can start from the step number 1 to step number 6. Okay. Yes, BMS, there is a advanced battery management system. First one, there is a power management control. Second one, there is a discharge and charge control. Third one, there is a fault diagnosis and assessment. Fourth one, there is a battery protection and data acquisition system. Fifth one, there is a current and voltage monitoring. Sixth one, there is a cell balancing and equalization. Seventh one, that is a thermal management system. Eighth one, that is a state of charge estimation. There is a SOC, SOH, that is a state of health, and SOT, that is a state of temperature. Okay. So somebody want to do research on the battery management system, then maybe you can consider the any parameter to control the battery of the electric vehicle. Okay. So this figure 2, there is a overall functional block diagram. Suppose you want to implement the battery management system for the electric vehicle. Okay. So this is your, from the left hand side, there is a battery pack. So we have to manage the voltage, current as well as temperature. So depend on the cell. Suppose you have 5 cells, then V1 to V5. Suppose you have n number of cells, then V1 to Vn. Then this is your sensor board measurement unit. We have to sense, we have to measure the every voltage, current and temperature, and then we have to control up to our limit. Okay, so we have to decide the limit of the temperature, we have to decide the limit of the voltage and current. So as per our demand, we have to overall control the our design algorithm for the battery management system. Okay, yes, so this is my the last slide. Okay, so I hope you got so many idea for your research as well as for your seminar. Okay, so if you really want to do the good research for your MTech thesis, okay, and if you want to do something for your local community, then please consider this presentation, and there is a second unit of your subject. Okay, and there is a part of your syllabus. Okay, so and then you can try to implement the your idea starting with the MATLAB simulation, and then slowly you can implement in the hardware. Okay, so key point from the today's class, that is a power electronics converters. Okay, application of power electronics converters in the different application, introduction of the electric vehicles, types of converters used in electric drives, and the finally battery management system for the electric vehicles. So thank you. Thank you so much for your attention. If you have any query regarding this subject, regarding this unit, that is a second unit, and there is a application of power electronics converter, then please ask me. I am happy to answer your question. Thank you so much. Yes, any query? Yes, student, any query? Okay. So from the next class, we will start the third unit, okay, and that is on the controlling and modeling of the electrical drives. So how we can control the motor and how we can control the torque and the speed of the motor. So step by step we can do the mathematical modeling, and then we will see the how we can controlling the speed and motor of the electric motor. Yes, any query, any debate? Okay. So thank you so much. And if you have any query, then please message me. And if you want to research on the electric vehicle, then also message me. Okay. If possible, then I will help you and I will guide you for your MTech thesis. Okay. Then thank you so much and bye bye.
Yes, sir. Thank you so much.